In this video, I will explain you what is dispersion. We know that dispersion is the phenomenon of splitting white light into its 7 constituent colors. What are them? Violet, indigo, blue, green, yellow, orange, red. So the process of splitting white light into its constituent color is termed as dispersion. Now how can we do this? So this is done with the help of a prism. Now I will tell you how the splitting is done. Now in violet I have all the colors, right? Violet, indigo, blue, green, yellow, orange, red. Now all these colors are having the same velocity in free space, which means the moment a yellow color, the moment violet, indigo, blue, green, yellow, orange, red being sent from sun, all these light rays are reaching earth together at the same time because it is having the same velocity in free space and also in air. Air and free space is almost the same. Okay. Now when they pass to a medium, then that will have different velocities. Okay, I could say, just compare this table. In this from this table I could say that different colors are having different refractive index. Violet is having more refractive index and red is having lesser refractive index. The reason is difference in their velocities of violet, blue, green, yellow, orange, red in a medium. In free space everyone has the same velocity, but in a medium they have different velocity. Different velocity give rise to the fact that they have different refractive index, because refractive index is c divided by velocity. So velocity of violet in glass is different as compared to velocity of red in glass. So in glass, velocity of refractive index of red color would be this, and in the same glass refractive index of violet color would be c by velocity of violet color. See, as these two values are different, these two refractive index also would be different. So this is red color, this is violet color, and this is red color. So what is the significance of different refractive index? The angle through which the refracted ray is bent would be different for different colors. So as violet is having higher refractive index, the violet color would be more bent from the, or more bent towards the normal. So this is the normal. So this is more bent, this is less bent. Red color is less bent. So this is red color light and this is violet color light. Now the same red color light will have a refraction, second refraction here, and that will come out. Now the violet color is split at this position, and that would be bent, more bent at this place. But here it is from denser to rarer, here it is from rarer to denser. So when it is traveling from here to here, then the refractive index would be just opposite of this, because we know that refractive index of 2 with respect to 1 is equal to 1 by refractive index of 1 with respect to 2. Okay, so anyway, considering this fact, we should understand that this will have, that the violet color will have different angle of refraction here, and even this would be different. In the same case, red would be less bent here and also from here, but here it would be more bent. Okay, here this is the normal, right? This one would be normal. So this is more bent and this one is less bent, because the ratio is just the opposite. So this one is higher here, so 1 by this value would be a lesser value at here, and here 1 by this would be this is lesser value, so 1 by lesser value would be a more value at here. So anyway, you can logically think and get the value that this would be refracted twice. Here in this case of red ray and here in this case of violet ray, it's the same thing. Now at here, from in the emerging ray, when you inspect, you can see violet and red color rays are coming as separate. Now we will see different parameters associated with dispersion of light. First thing is angular dispersion. What is angular dispersion? So when occurring dispersion, violet is making one deviation of delta violet. So that is more, because violet would be deviating more, and we can see violet here. Now red would be less deviated, and that would be the angle of deviation is measured with respect to the incident ray, and that is this much angle. Now this angle is nothing but angle of dispersion, the angle in between red and violet ray that is emerging out from a prism. So how can I get this angle? That is nothing but the whole angle, this when subtracted with this. So this is being subtracted by this, that is deviation of violet is larger, and that is that minus deviation of red. Deviation of red is equal to angular dispersion. Or I can say when deviation of red is being subtracted with deviation of violet, then I could say that is angle of dispersion. Okay. Now next thing is dispersive power. So we have different angle of diversion for different colors. Violet is having the highest angle of deviation and red is having the lowest angle of deviation. Now dispersive power is nothing but angular dispersion divided by mean dispersion, and mean dispersion is calculated with respect to yellow color light. So we are going to take the mean of this, and that is with yellow color. So dispersive power is angular dispersion divided by mean dispersion, and angular dispersion is delta V, that is the deviation of violet color ray with deviation of violet color ray, that is delta V, and that is that minus deviation of red color ray, that is delta R. So this is giving us angular dispersion. Okay, that's all. Thank you.